Explore the latest innovations in AI-powered SASE at SASE Converge, Palo Alto Network's premier virtual event. Featuring experts and technologists from companies across the globe, this event reveals how SASE is transforming IT and end-user experiences while raising the bar on security. Watch on demand now at saseconverge.paloaltonetworks.com. That's saseconverge.paloaltonetworks.com.
Welcome to Heavy Networking. If you have strong opinions about whether your network infrastructure as code should be stored as JSON, YAML, or something else entirely, you've found your tribe. I'm Ethan Banks, along with Drew Conway Murray. You can follow us on LinkedIn, Blue Sky, and the Packet Pushers Community Slack group, which you can and should join for free at packetpushers.net/community. Our show today is about modern telemetry and network observability in the post-SNMP era. What do you mean post-SNMP era, Ethan? I use SNMP every day. Yeah, of course you do. And you're gonna for some time to come. But the times they are changing, as evidenced by this question that came in from Nikolay. Nikolay says, while telemetry, gRPC, etc., is becoming more and more popular, there are very few real-world use cases I could find. I would like to hear more about real-world deployments, especially the amount of data people see generated by hosts and how I'd store that and so on. So I gathered a bunch of people who are on the cutting edge of this kind of thing, network automation and modern telemetry and so on. So joining us for our discussion are Roman Dodin, John Howard, Ryan Shaw, and Josh VanDeraa. All these folks have hands-on with modern telemetry and experience to share in this round table style chat. So, gentlemen, I'm going to prompt each of you to quickly introduce yourselves, just a sentence or two. Say your who you are and what you do, and then the AI that transcribes this podcast will know who you are, and hopefully we'll get it all correct. Josh, starting with you, who are you and what do you do?
So Josh VanDeraa, I'm Services Director at Network Code, part of our professional services side of things. I've been also an author on the Modern Network Observability book that came out recently, and so I've been part of our telemetry and our network automation space all together with in the network realm.
And there's a course that you did for us on using Ansible for network automation that lives on the Packet Pushers YouTube channel. So welcome to the show, Josh. John Howard.
Hello there. Thanks for having us. My name is John. I run the network team at Proton. So we're a privacy company that tries to make sure that privacy is the default on the internet going forward. And my role there is to lead a little band of nerds building networks in on-premise only, delivering all manner of services to our ecosystem.
Excellent. Thanks for joining us, John. Roman Dodin.
Hi, everyone. Great to be back. Yeah, my name is Roman. I'm part of the Nokia's product management team responsible for SO Linux and IDA. We've been doing gNMI for as long as I can remember myself. I think I fired off my first gNMI C request before I did SNMP get. That's how young I am, I guess.
We also got called out for being old by Roman. Okay, yeah. Okay, Ryan Shaw.
Yeah, okay. I'm Ryan with a bruised ego. I'm a network architect at Zscaler, and we're responsible for helping businesses secure their traffic and applications.
Excellent. Okay, guys, let's get into this discussion here. I'm just going to open this with I don't know if it's an obvious question or not, but the question is this: can I build a network observability platform without SNMP, or do I still need SNMP today? Now, I think that's a leading question that I haven't actually seen that solution. Almost everything I've seen that involves modern telemetry, still there's an SNMP role to play somewhere there. But what do you guys say? Is it possible to actually build network observability without SNMP? And if so, what does that look like? Roman, you started this thing and said, my first call wasn't even SNMP, it was something else. So maybe you should have an opinion first here.
Well, yeah, I think you can definitely build one. And probably the problem that you haven't seen something on the table that's readily available is that we are not there yet from the open source perspective. There are certain commercial versions of network monitoring systems that use streaming telemetry. But at the same time, the common denominator is still SNMP based. That is why just the prevalence of SNMP based solutions is, we have more of them rather than gNMI based.
So if it's possible to build without SNMP, even if it's not as easy, there's not as much open source support and so on, what would that actually look like?
I think it would look like exactly the same as the SNMP based one, right? How do you picture yourself an SNMP monitoring system? You have a bunch of MIBs, you get the data out, and then you graph them in a nicer graph. You do the same with gNMI. You just need to have the gNMI support on your networking gear. That might be a problem for certain vendors, and that is probably one of the problems that we see as an industry. It's kind of just not there yet, while SNMP is like a common denominator, as I said, for many network operating systems. But that would be the same. You just subscribe to the paths that you want to collect and graph them in a database. The tooling is a bit different. You use different tools, you use different databases, but essentially it's just the same: extract, transform, collect, and draw.
But would I need to sort of build my own observability backend then for that database and all those collectors to get that gNMI?
You don't need to. There are plenty of open source solutions, free and commercial. So you have telemetry collectors. gNMIC, Telegraph are the two most commonly used one, I would say. You have databases: Prometheus, Influx, Victoria Metrics, ClickHouse, lots of them. It's not the shortage of tools that stops us. It's probably the adoption curve that we are kind of getting on ramp.
I think I'm going to jump on that one because the AutoCon 3 was last week. Was it last week or was it week before? Bloody
2
hell.
Week
weeks ago.
before.
Time flies when you're having fun. But we had a roundtable discussion on this in where Dinesh Dutt and Justin Reiber from Suzy Q and Kentic fame hosted a roundtable discussion about this exact topic: modern observability and where to go. And it will shock nobody who knows me that I may or may not have been opinionated in this conversation. And I think what it boils down to for me, my observation from the last couple of years of kind of banging my head against this wall, is I see what Roman's saying about, okay, well, we've got all the tools, but the adoption is probably the problem. And I think that there's actually a slightly easier answer. You know, Occam's razor is the simplest solution, is the best one. It's that SNMP works too well. And one of the frustrating things is that there is, and I mean this with all the love and respect in the world, you've got tools like LibreNMS, where you can literally download a Docker Compose file, Docker Compose up, type in a couple of IP addresses and SNMP strings, and within about 5 minutes, you've got 175 metrics per device, pretty graphs, all of the things you could ever imagine, like an alerting engine, a billing engine, you name it, it's all there. And, you know, Rome wasn't built in a day. That tooling goes back, the heritage of that goes back many years. And a lot of the value here is that somebody, some poor soul, spent the time going through an SNMP MIB, finding that MIB is interface packets per second, and that one is some rate. This is you know, the speed that it's linked at, and they've mapped this in a database somewhere such that when you go and say, here's the device I want to talk to, and here's its community string, behind the scenes, 700 little processes kick off and produce this tooling that says it's a Nokia box. That way I'm going to use these MIBs and I'm going to get this information. And off the back of that, I'm going to be able to give you some consistent graphs. And what we need is the LibreNMS for telemetry. This is my personal mission that I would like to tear into over the next 6 months. And this is what was quite interesting, was in that roundtable discussion with 20 other operators, the service provider is solved. Everyone in the service provider space has got tooling coming out their backside, which works absolutely fantastically. However, I believe the other side of the story, the data center, the campus, they don't have this. We're reliant on the tooling that just works. And that's the problem I think we need to fix.
Yep. And that's kind of where I get into it. And becomes usually a business case scenario type thing of when you're talking things on scale at remote sites type thing in a branch scenario, it might not be as feasible to be going with gNMI side of things. But you, as a network organization, definitely want to be playing. For me, the biggest thing is putting everybody into the same sandbox from a visualization and alerting perspective, going down that path and having those capabilities. The nice thing is, even though, the question is very specific, is this can you do it all with gNMI? And I think the simple answer is yes, you can, given the right hardware. But then but should you? And going down the SNMP path, hey, we know where the SNMP is for CPU. Do I need CPU metrics every 10 seconds, every minute type thing? What is that actual piece? What's the fans? But then there's also the close, especially in many enterprises, the close cousin to networking spaces. What about the PDUs and the UPSs? And you quickly get into the realm of A, do you need to have it that quick? And then B, do those pieces of hardware that we were happy to get SNMP metrics to say that, the UPSs, not even all those have the metrics capability, and bring those together. So,
Yeah, that is, it's not just network devices that we're gathering telemetry from. There are other components of the data center dealing with environmentals and so on that are super important for what we're doing. And are those likely much more slow to adopt modern telemetry devices? We don't want to leave them behind.
Yeah, and I'd say it's even more than just in the data center, right? Networks go pretty much everywhere, right? And I think I've been starting to have this. I grew up kind of in the retail branch world of networking, and that's still kind of hey, somebody says you do networking. My mind's picturing those branch sites and all those pieces as network, whereas I think a lot of others think, okay, what about the data center side of things, right? So.
Yeah, I'm going to say no. I'm going to say no. You can't do it with just gNMI. And this is, I have a very specialized, network that's full of the most cutting edge, high bandwidth stuff. So I could use gNMI. I can use all the latest protocols, but I'm still not going to, because the value of gNMI over SNMP depends on the data set you're trying to grab. So obviously from PDO, right? Or stuff like that, it's not going to support gNMI because the vendors don't need to. So SNMP just works, as John said, and they don't need to have the 10-second, 5-second data, a 5-minute data polling period, perfectly fine. Also, a lot of people, if you give them a 5-minute polling period, so let's say an interface drops from that point, you might have about 9 minutes of total lag time between polling periods where something actually happens. Are they actually going to react so fast that they need a 10-second polling period, like a 10-second subscription period? So if you give them gNMI, go, hey, you get data, you get metric every 10 seconds. Well, it's going to take me 30 minutes to even get to, a runbook or a team or a process notification. That value is left. So you're telling an organization, convert all your stuff to gNMI so you get data faster that you still can't act on fast enough compared to SNMP.
Don't get me wrong. I have a lot of sympathy for that point of view, because it's the truth. I mean, oh my God, I've got 15-second poll intervals from 5 minutes. Now, whenever something happens, I can jump on it immediately and operate immediately, which if you don't have a knock, what's the point? Like, I'm with you on that. I totally agree with that point of view. I think the other part, though, is that I have lost track of how many times I had something flapping that it took 3 polling intervals to 15 minutes to understand I needed to act. In the meantime, I've got customer tickets that have started to pile up. These two things are not these two things are in conflict, right? So I think one of the things that drives me is that just because you can do 15-second doesn't mean you should. You can still do 5-minute or 10-minute polling with gNMI or any other kind of these protocols. And I think where we go back to again is, unfortunately, because we have a well-trodden path, to use the Netflix analogy of the paved road, people will walk down the paved road rather than try and make their way through the brush. And at the moment, everybody is looking at gNMI and telemetry as a general kind of problem, as I need to start at base camp and I need to get to the top of the mountain. And it's huge and it's daunting and I don't know where I'm going to go, because the documentation is decent, but I'm back in that day 20, 25 years ago where I need to go and find the MIB and go and find the right part of the tree and find that one magical little path that's going to tell me where my drops are. And it's I ain't got time for that. I'll just use SNMP. It works. So this is where we've got this kind of friction argument that needs solving. And realistically speaking, I strongly believe that we should use the collective power of all of the operators out there that are trying to solve the same problem on one project. And this is what we don't have. We don't have a focal point right now. That's the bit I believe we need to try and find an answer to. We need a focal point like LibreNMS where someone can come along with a merge request rather than building the whole stack from the beginning.
Okay, part of that last exchange, the argument was we don't need faster polling interval because a human can't react to it any faster. Yeah, but we're also automation people. We were all just talking about AutoCon a bit ago. Wouldn't you be feeding gNMI telemetry to an automated process, whether that's an AI or not, but something that is observing those events coming in and then can react to them in a timely fashion? The notion of being proactive, because to go back to Nikolay's question, he's looking for the use cases. Where are the use cases for gNMI, and wouldn't automation be one of them?
Very much so on this one. I think there's a line that I start to get into the modern network observability, really looking at how vehicles have evolved. And specifically cruise control. So the cruise control back at the start for vehicles started as, hey, you set the speed and it stays at the speed. There could be a car right in front of you, 15 feet, a couple meters in front of you. And if that car's doing 45 and you're doing 70, you're gonna hit that thing pretty hard, right? If you don't take action. But nowadays there's radar and adaptive cruise control that really starts to take a look at on a high frequency and starts to automate your speed at that point even further to adjust. And so it really comes down there, Ethan, of what are you responding to for events? And making sure you get the right telemetry for that. It's not just saying, hey, go give me all the things. I think, as John said, you fire up LibreNMS, you have 175 different metrics. Do you need all 175 metrics at that rate? Maybe you just need interface speed, and that's a good enough, and let's get that down to 5 seconds or 10 seconds type thing. Something for you to be able to act upon.
Hey everybody, let's take a quick break for a message from sponsor Palo Alto Networks. Today's businesses are adapting to a hybrid workforce with employees working at corporate branches, home offices, and on the go. Digital transformation initiatives and new AI capabilities are key to maintaining relevance in a changing global marketplace and transforming operations with enhanced automation and increased productivity. To get a handle on all this, you're invited to join Palo Alto Networks at SASE Converge, the industry's premier virtual event. Available now to stream on demand, SASE Converge brings you experts and technologists from leading organizations across the globe who reveal precisely how AI-powered SASE is transforming IT and end-user experiences while raising the bar on security. See why Palo Alto Networks was recently recognized as the 2x leader in the 2024 Gartner Magic Quadrant for single-vendor SASE, and get insights on enabling GenAI apps for your workforce, the latest innovations for the industry's only integrated enterprise browser, and creating a seamless IT experience. Watch on demand now at saseconverge.paloaltonetworks.com. That's saseconverge.paloaltonetworks.com. And now back to the podcast.
Well, this is one thing that, as a newer convert off Juniper and onto Roman's beautiful platform, I've definitely had some enjoyment, because when I first started to touch it, SNMP wasn't really an option. Because you guys never did it. You're like, no, we've got this better way. So in some senses, I and a bunch of other customers had to beat Roman around the head with a stick saying, can we have SNMP, please? And he's like, but why? And he wasn't wrong in some senses, but at the same time, this is kind of like, this is a recognition and an acceptance that this is where the industry is at this point. And I think that you're quite right that, what is my cadence? What is my interval? What is the things that I need? And one thing that is really, really interesting that not a lot of people who are kind of stepping into this area realize is that there are a number of different ways that you can do a subscription to a device. And I think one of the most important things for me is that I can choose to, for example, one of my options that we're going with right now is all of my states are pushed on change. So I don't go to the box and say, is that BGP neighbor up? Is that BG neighbor? Is that BGP neighbor? Is that BGP? And I get 7,000 yeses. and store them on disk. So to Nikolay's question, how much storage do I need for all this data? Well, if nothing changed, nothing, right? I store when something happens, but that's useless to me when on a port counter, because guess what happens? It changes every millisecond, and I don't want to get an on-change for that because it's a fire hose of integers just going upwards. So for those, you do a subscription that says, give me a 15-second sample, give me a 30-second sample, give me a 1-minute sample, whatever. And where I think that we're kind of clagging at the moment is that, as I said, LibreNMS, I can roll it up, I can just put something in and I just get some data and I'm happy. And the problem right now is that to do all of that plumbing, whether it's gNMI or Telegraph, I need to create lots and lots of different configuration blocks in a single file. And it starts to become a bit unruly. So to tell a mini story about what we ended up doing inside of my team, I had one engineer booked on this for almost 6 months. And not 100%, but a lot. And what we ended up at the far end was like 2 Git repositories. One that's Ginger 2 rendering, templates that are kind of producing the subscription options that I'm going to need. And then the other one is kind of the rendered configuration file that I pull down with to my machines that I run with Docker on my gathering nodes. And it works really well. It's pretty neat. We've got this ability to be very granular and very specific about, I want this metric in this cadence, and I want this particular metric to be pushed down my throat. And what we're trying to do now, which is something that I'm trying to spin up off the back of Autocon Free, is turn this into an open source project that people can collaborate on. Because I'm a little bit frustrated. Maybe it's the inner left-wing lunatic in me that says people power, right? I've got a bunch of people I know who are really good at making Grafana pretty, but they're useless at programming. I've got a bunch of people I know that are useless at Grafana and can't be bothered to make the colors right and the scale, make it like gigabits rather than just a really big number. But they're very good at programming. So here I've already got in my team 2 different people from 2 different areas that mesh. What if there was 50 people like that?
John is a streaming telemetry socialist. Is it fair to put Roman on the spot, who seems to be like the gNMI native here, to maybe talk about a couple of real world use cases that he's encountered for streaming telemetry, since that's sort of the thrust of the listener's question?
No, yeah, I think I would rather rely on others in the panel to cover the use cases, because my use cases are quite specific, given that the customers who deploy gNMI tend to be in the hyperscaler domain first. That's like by nature of things, they are the first adopters of that, and they were requesting this when we just started with Astro Linux. But I wanted to kind of summarize what I've heard in the past 10 minutes. I still believe that you want to have high fidelity of data for certain counters, even if you do not have the NOC team reacting fast to them, and probably that's not even a good use case. You don't want humans to constantly monitor the graph and then react on a spike. But you might want to monitor like queue depths or some counters that might have been lost if you poll them with 1 minute interval. It can be flat 10 seconds before and 10 seconds after, but it can be a spike in between. And if you don't have this high fidelity, then you lose this data. And it can be useful for accounting, for example, if you want to rewind back and see what happens during the outage, like maybe some port queues or things like interface counters that have been dropped or spiked as an example. So this fidelity is quite important. I don't think that everybody should subscribe with 1 second granularity to port stats. It's not even, it's not useful. You will have a lot of waste data, but you might want to have it for certain fields. And the second field that John mentioned that was like spot on, the on-change telemetry is what actually brings gNMI to the spot, like what puts the spotlight on it. Because on-change is something that you do not get with SNMP at all. Like you have traps, but traps are not on-change for state and configuration data. And on-change is key for automation. Like if you want to subscribe to events and act on them, like build those closed-loop automation systems we all want to have in our networks, you have to have that. And this is the only protocol or interface that gets you this. So yeah, certainly gNMI might not be the only answer and the golden nugget of streaming telemetry, but it is one of the ways that gives you a lot of capabilities, a lot of things that you can build modern networks on.
And I'll challenge just briefly that the on-change isn't required, but it's definitely it's in that path, right? Of you could do the same thing with syslog and have a logging event, but again, you still need belts and suspenders within any kind of event stream type thing, whether that event is gNMI, SNMP, traps, like you said, or down the path of syslog. But Ryan, I know you want to say something there.
Oh yeah, just real world experience and definitely like, I'm using gNMI mainly for, because of shorter polling period, right? Like, a 10-second polling versus a 5-minute polling period. Like, yeah, if you miss 3, like John said, that's 15 minutes versus 30 seconds. It's a huge thing. And I do have automation in my stack. I do have a closed loop, so I can respond to events quickly. And so I want stuff that I really want to have certain counters certain counters I can just send to SNMP and just leave it, so I don't have to add more configuration. But so far, gNMIC and Prometheus Grafana has been a pretty solid stack, and be able to, the dashboards are the hardest part in this whole setup. And also, yeah, getting people to get more kind of DevOps, like, like configuration files. People are used to like, other stuff, and they're more used to it. But, coming from LibreNMS to like, Prometheus exporters or something like that, it's a big shift. But yeah, it's that polling period. The fidelity of data for transient positions, I really don't care too much about, because there's usually other factors in play that lets me know an event has happened. And it's really hard to trace back. I know a lot of people go, oh, that microburst happened. I want to know exactly what happened to that microburst. I'm like, but really, do you really care? Are you really concerned about your network, about the 1%, of 1% or 1% of an hour traffic happened versus, your steady state that your customer didn't even understand?
It depends, right? It depends on who you are and what you do. Some shops that I've worked in, well, one shop particularly that I worked in, yeah, actually we would have cared about that because it was fintech, and it might have implied payment transactions that were dropped during that microburst, let's say. And so being able to pinpoint it so you could answer your top tier client exactly what happened at 2:34 a.m. because they saw the drop and they want to know, that might actually happen. But for the most part, yeah, I agree with you. The extreme granularity isn't worth the trade-off in additional polling cycles and then the storage requirement on the back end to hold all of that data historically.
But you're going to see counters, you're going to see updates happen regardless, right? Because they're all going to be atomic numbers that just get updated, right? So if you see a burst happen, right, and let's say your queues get, your buffer drops and stuff like that, or you have output or input drops depending on your queuing system of your hardware, like you're going to see that happen regardless.
Yeah.
So yes, yeah, it's really if your company needs like a 10-second window, or do they need like a 4-minute window of when that happened? You still know what happens. You just need to know like when that window is.
Yeah.
I love gNMI. Don't get me wrong. I am full gNMI. I'm moving as much stuff as I can to gNMI. I'm just trying to say that, the pragmatist, like the practicalist of like, hey, just because you have this tool doesn't mean you have to evaluate your use cases and stuff like that.
So I want to drill into something you just said there. You said, I'm moving as much stuff to gNMI as I can. What is your driver for that? What is better about it that you're going, this is the way I'm going to leave SNMP and use gNMI instead to gather this data?
I mean, I think it's what everyone said. It's your polling windows, and you're dealing with polling windows and everything, but polling windows are a pain, because if you missed one, then it's an entire another polling window till you get something else. So the smaller that gets, the way better detection time you get, right? It's not even just a linear thing, right? It's by a factor of 3 or 4 or 5, depending on how many things it takes to get that polling window to show the accurate data. And also the fact of, on change and sample, and you can even do a sample, and I think you can do a sample and on change. So while you're sampling, you can still do sample and on change. There's so much ability with gNMI that's pretty darn great. And OpenConfig standards are really good for metrics. Configuration is another thing, but like I can go to OpenConfig on most vendors and go, okay, cool. I can grab interface or BGP stats and stuff like that, and I can usually just type in the path and get it.
How did you decide how much data was too much versus the right amount? Is that something you had to like tweak and play with, or?
I mean, yes, and it depends on how much you want to store and run your instances and stuff like that. My thing is if I can throw away data after, a couple, besides just the counter data and Grafana or something like that, anything else, I don't need to store that data, right? This is all just like, okay, as soon as I take this and turn it to basic counters and reduce the data set, I'm good. I don't need a flood of information after like the point that happens that I can interact with on the event.
And also time series database are very good at kind of combining the data. Like you might think that you get a lot of counters, but they do some smart algorithms that make it condensed. So you don't really have, terabytes of data by just streaming 10 seconds every day. You will not have that problem. And of course you can then roll back. You keep it for historical reasons for, a couple of weeks, months, and then you just roll it up and it becomes your historical data with maybe 1 day granularity. But your immediate, like 2 weeks, 1 month, depending on what is your data storage requirements, these data is really high fidelity then.
There was a very interesting discussion on this during the roundtable at AutoCon. And a key takeaway was a lot of people that there's an old friend of mine, Simon Linian, is a veteran network engineer from Switch here in Zurich. And he was sitting there going, but Toby Oka wrote MRTG like 30 years ago and it still works. And yeah, he's right. But I think one of the things that was interesting was during that conversation, there was a big pushback because there's this big phrasing, there's this magical word, there's this big rainbow on it called, I'm flaking out. I was so busy coming up with the rainbow analogy. I forgot what it's called. Cardinality.
Mm-hmm.
Now this is like a toxic word that you throw into the mix when it comes to telemetry and metrics, and it makes everyone really sad because if you've got too much cardinality, your Prometheus will kaboom, and all sadness will happen. And I've got a fun story about this one. We had too many metrics in our Prometheus instance, so we installed Victoria metrics and we federated data from Prometheus over to VM so that we could have this high cardinality, scale out storage. It was a wonderful thing. And don't get me wrong, I'm not dunking on those products at all. Some people have that need. But what's interesting is Cloudflare, one of the largest network operators in the world, with 550 plus POPs and God knows how many terabits of traffic per second. They only use Prometheus, last time I checked, and they have 2 tiers. They have the capture Prometheus in the data center, which maintains 2 days worth of data, I believe it was, if I remember correctly. This may age badly, who cares? They keep 2 days of data on site, and then they create summaries, and then they federate only the summaries to big Prometheus instances, the regional ones, one in Asia Pac, one in Europe, one in Americas. And the idea is if you want to get summary data, you go talk to the big fat one that goes back 2 years. But if you want to know what happened just now, you point your Grafana instance at the data center or that POP that you're trying to look at. And they don't have problems with scalability. They don't have problems with this stuff. And I think I know why. And one of the big, there was a fantastic ooh when we said it, but the problem is that gNMI turns into, well, not gNMI, let's be broad about this. Prometheus turns into a data swamp, not a data lake. If you poll the node exporter, the first instance of any exporter you'll install in a telemetry landscape, you know what you're going to get? Like 700, 800 metrics. And you know what you do? You touch about 10. And this is the exact same problem we had in SNMP back in 200 years ago. So what we did was we self-regulated. We stopped polling every single interface. We only polled the ones that were up. We stopped getting, what are all of these really weird esoteric MIBs that just return a 0 every time? Throw them away. We don't need them. So only focus on what you need. And again, this is why it becomes a bit boring because in LibreNMS land, I know I'm a bit repetitive here, they've gone and done the hard work. And in gNMI land, we're doing it ourselves. But to kind of steer off in another direction, there's something that Ryan said, which was so close to kind of, I was like, yes, but there's one thing that no one's said yet. Why is LibreNMS great? All these graphs everywhere. I don't use all of them. There's one thing that you don't get. It's called correlation. Ryan mentioned a bunch of things. Why are these queues deep? Why is that BGP table got? You can't go to MRTG and say, find me all the times that this went above a certain threshold and this went above a certain threshold, and now fire an alert that says I've lost this particular service. Because all I can do is monitor one particular metric, one particular instance of an SNMP MIB. And when it goes over that line, I can then say that's gone and end up with 50 alerts because one DCI has gone down.
And that's where
gNMI gives you this aggregation ability, this ability to sort of say, here is 5 things that have happened. That means one big thing has happened. And that's what you get when you pull this into a database.
Well,
And
hold
I'm
on.
gonna go-
I don't think that's gNMI. That's not that. I mean, like for instance, if you're using Grafana, right? Like Grafana tree and a rule tree and Prometheus too as well. They're use a PromQL and you can gather all that information. SNMP, gNMI, metrics, whatever, right? That's just a thing, right? You just set multiple data sources and then you set the alert conditions and cool. So let's not say that's just gNMI in itself versus SNMP in there.
It's telemetry though.
Yep. And
Right.
so I'll tie those together. I'll tie this all together side of things I go back to the events piece, whether that, again, doesn't matter what the event source is, but an event, you have exact timestamps of events, right? And so now with the exact timestamps, you have, okay, let's just call it 1 second. You could go into milliseconds and everything else. But then if you're SNMP polling in metrics, as you try to put the event and the metrics together on the same graph type thing, now you could have that 5 minute, and actually it might take even more than that. It might take up to 9 minutes in a 5 minute polling type thing before that shows up. And now you have this event that shows up. Let's just say it's an annotation on Grafana, right? A line that says this event happened at this time, whether that's a syslog change, maybe a pull request type thing, that shows up there. But then it takes 9 minutes for that graph to indicate that there's a change, right? And so that's where some of these benefits, we've been talking up, the SNP still exists, it's still good, but again, into these rich visualization capabilities of, it's not just these old dumb graphs that you can't interact with type thing versus modern graphing with that, to have that strong correlation data of events with the metrics. That's what really ties it together in my book of why gNMI.
And the SNMP exporter is a thing too, guys. The SNMP exporter is a fabulous piece of software that allows you to manually plumb in those wonderful ASN1 MIBs, and it will go and fetch them for you on the cadence you want and store them in Prometheus. Like, to answer that point that came at the very, very beginning, what about my PDU? What about my UPS? Yeah, sure. Use SNMP exporter, go fetch the data you want from there, store it alongside all the other things, and visualize it in the same way. Because realistically speaking, the power of a telemetry stack is that you end up in this position where you do have multiple things all sitting together in the same space and are able to start to turn individual metrics into insights. And I know I feel like I'm selling something. Give me a job, someone. Right? But this is the other day I was able to sit at the Packet Fest in Zurich, where the Wireshark folks and NTOP kind of come together, and Thomas Graf, a distinguished engineer at Swisscom, who is also on the NMOP working group at the IETF, was demonstrating the art of what's possible in the service provider space. And I've got to tell you, they are miles away. They have got some rich information that they gather in. They're doing correlation. They're doing anomaly detection. They're kind of interspersing BMP with standard telemetry data, with flow data, and they're able to pretty much autonomously say that network outage that affected that customer was because of this BGP change that was caused by this interface going down, which was actually because of this link failure over here, which caused a real mess in our overlay. And they're looking at a dashboard and saying, this is what it was, lads. It was there. They're pointing at it. And I'm like, I'd just love to know what my throughput was on a Wednesday.
I'll go a little bit deeper because, on like kind of our stacks and stuff, So the main reason I'm doing gNMI is not for the dashboards. I mean, for the alerts, it's great, right? I get faster alerts and I get automation, stuff like that. But also, it's my health validation system. Like after I do a change, I want to validate the device as soon as possible after the change. So there's any impact, I can roll back quickly, right? Because the customer trust is absolute in our space. And so if I have SNMP, I can be waiting 8 minutes, 9 minutes, 10 minutes for that to really check, especially like traffic. I mean, I have to check a couple times for traffic or interface errors, make sure they're not increasing. So I have to check twice. Those polling intervals hurt. So I need it to be fast, right? If I can get detection, my entire health check for my entire network under 30 seconds for the site, I'm happy. Because then that means I can roll back under a minute and a customer at most will get a minute of impact. Something to look at dashboards. I'm just like, oh, cool. Like the dashboards are cool for back, and people are not going to look at like second to second. It's for the alerts, and then it's for my health check service. Like that's why I use gNMI. Is something that if someone's going to look at 5-minute intervals aggravated anyways on a dashboard, and because they're used to, and that's just kind of they're not going to say, oh, this was 2 seconds. They're just going to go look at graph, go, oh, line goes up, line goes down, cool. But the alert part is awesome, and be able to check immediately and get those metrics responsive. And also, like I think Howard, cardinality, and again, people that aren't familiar with telemetry and OTel and all that stuff like that, cardinality is just the different types of metrics and the directions and stuff like that. So when you get time series or something like that, it's also aggregate that. It has low cardinality. It's like, okay, not a lot of stuff that's different. So I just explained it because when I first heard about cardinality in OTel and observability 2.0, I'm like, what the heck is this word? And also I like the fact of I don't want to use LibreNMS. Because if I use prom exporter for SNMP and I use gNMIC to set stuff into Prometheus data and stuff like that, I could use the same stack that the server people, that the software people are using, stuff like that. So I'm like, oh, lots of data. We have some huge systems because we're supporting everything else. Like, yeah, if I add another, a couple terabytes, like, a couple hundred terabytes, like, cool, whatever. But if like my own little network thing, and I'm like, okay, well, I have this devices, and I have to really careful about this, and then I have a different stack over there. Just go, no, it's all the same stack. I'm putting it all into the same databases. I'm throwing it up there, and yeah, networks I tend to have pretty much low cardinality because you are just not doing 175 metrics per device. I've never met anyone that if you wanted to choose, you can. That's totally up to you. But if you're doing 175 metrics per device, you're not looking at them.
Well, you solved the storage problem in an interesting way, Ryan. Hey, I'm going to use the system that someone already spent a lot of money to build a big storage backend on and use that. I'm not going to add that much to it, really. It'll be fine. And now you don't have a problem.
This was a conversation I was having with Drew recently where, if you can leverage something your organization already has, do it. Absolutely do it. And you'd be amazed how many of these systems that we think we need, like networking is moving into this kind of era where, everyone is an engineer, they're a network engineer first, they're a software engineer second, they're a security engineer third, they're a flipping telemetry expert the next. More and more and more, we're wearing more and more hats. They're just getting into like stovepipe level. It's insane. So if you can get to a point where you can steal someone else's work inside your organization, what's the phrase? Imitation is the greatest form of flattery. Like if you can rip someone else off, go for it, right?
Well, I was being a little silly, right? But there's a larger point here, which I think is worth making. If I can leverage the same visibility systems, observability systems that everyone else in the IT stack in my organization is using, I can now put network data alongside of application stack and whatever other monitoring data is happening, is being viewed, and make it part of that same view. So there's a lot better chance that things are going to be integrated and correlations can be made. Networking's not this thing off to the side that everyone else is like, I don't know, talk to the network. Maybe they changed something and that's why things are slow. Now you've got the same graphs, same observability on the same pages and dashboards and so on. Ryan, I don't know if you've actually had an opportunity to do any kind of integration like that, but it seems like it'd be a lot easier.
Yeah, no, definitely. And then I can just, it makes it easy for me. I'm only querying one system. I'm not querying 10 different systems to get all the metric and correlation data. I'm querying like one system. Going, cool. All right, cool. This is a different alert system, different page. Awesome. Yeah. I mean, granted, we networking will always be kind of different because, right, like we're using gNMI. Rest of the software systems using OTel for observability 2.0 or whatever 3.0 will give them and stuff like that. But, and structured logging and such. But most platforms support all of that, I mean, the Influx, Prometheus, they support all the not, and then if you want like logging, if you do the LGTM stack, which is, Loki for logging and Grafana and stuff like that, and Beamer is Prometheus basically. Like, yeah, it just supports it all. Doesn't matter what I throw at it.
So to try to put a bow on Nikolay, sorry, go ahead, Josh.
I can't state that enough about the connection of the application side of things, because when you take a look at the greatest network, if it doesn't have an application to serve, what's the point of the network, right? In the end, applications are what ride on the network, and why you want to get things from A to Z across the network path, right? Get down. And so having that application monitoring or connecting the network in with what the applications are doing and the compute, it definitely will reduce the mean time to innocence of what the network team has looked at.
Invoking Greg. Mean time to innocence.
Josh, I would argue that the network exists for its own sake because networking is just that awesome. But I guess we got to carry applications.
Someone has to pay the bills, right? And it's usually not networking.
There's a fun one where you can sit there and say, like, one of my biggest bugbears that I cannot stand in the current marketplace today is 25 gig copper networking. 25 gig DACs should not exist. They are toxic and terrible because the FEC settings you need to configure on these devices vary depending on the size and length of the cable, or the quality of the cable, or whether or not they plugged it in and bent the wire too much. Telemetry gives me access to FEC configuration data, but also gives me access to the error counts and stuff. So I'm now able, when someone says, I've got errors on my port, but I don't know why, I've got, here's a FEC dashboard. Is your server showing up on there at all? Yes, it is. Well, it's time to change your cable, sir. You know how much time that saves me? It's ridiculous.
Oh, yeah, FECs and optics. Oh.
It's not, but that's the worst thing. Like an optic, I don't care, because if it's 25 gig, it's FEC 74, everyone's fine. But if it's a cable, it could be FEC 74, or it might be FEC 91 if it's a crappy Chinese cable. Or if it's a decent cable, but it's 4 meters long, it's FEC 108. And did you know that FEC 108 has 4 times the latency of FEC? And it's like, come on, guys, no. Stop it. Just put a flipping AOC in and move on. But anyway, it's nice to be able to make correlations. And these correlations drive the business. So the mean time to innocence dashboard, I've got 3 of them. One of them is relating to FEC. One of them is relating to TCP retransmissions. I don't even get that from the network stack now. I'm getting that from Node Exporter. And the last one is just some dumb petrol gauges that just show how utilized links are. Petrol gauges are generally the most useless thing for a network engineer, because all it's telling you is, right now, you're that. It's a point-in-time measurement. What you want is a graph, so you can see, but with a petrol gauge, a developer can look at it and go, ooh, hot, it's red. I'm going to call someone. So sometimes the visualizations are a little bit silly, but like you say, throwing it all into the same platform, giving everyone the same lingua franca. They have to learn PromQL, PromQL's it, done, off you go to the races. That is an immensely powerful tool. Because realistically speaking, it's a bit frustrating that we don't have the LibreNMS for telemetry yet. But the day we do, I'm going to dance around.
Before we close, I want to put a bow on Nikolay's question about storage. Compared to traditional SNMP polling style of system, which takes... I mean, the amount of storage on the back end is going to vary widely depending on the system, the amount of polling you do, the number of objects you're polling, and so on. For those of you in the gNMI world, are the storage requirements particularly different, or does it go back to you have to use discretion in what your what your rate of inbound is. I don't need to have a 1 second interval where you're sending me information. Is that really how you manage the amount of data? And again, you get into specifics of how much data you need to have on the back end, and then maybe correlate that to the number of devices on the network and so on.
I'm going to give you a scary number.
Okay.
Our entire telemetry stack, which includes the whole business, is like 6 petabytes.
That's a big number.
It's a big number.
But that, yeah. Do
But
you
my
have any
corner
sense
of
of how
it-
much of that's networking stuff?
My corner of it is, I need to double check this now, but let's just say it was 40 gig, because I think it might be 400, but I think it's 40. Decimal places move around a lot when you're talking petabytes in the total stack. So I need to, I will double check that, but I'm actually pretty sure.
But 40 or 400 in a scale of 6 petabytes, that's irrelevant. I mean, that's a rounding error. That number it just isn't a lot.
But
And how much telemetry are you gathering?
What is the thing? My capture layer is 50 gigs.
Okay.
But this is the thing. I break this up into 2 tiers. I have a capture layer where I have just a Prometheus instance with the whole telemetry stack with Grafana, gNMI, Telegraph, because I need both for some weird reason that no one's ever explained to me. A couple of exporters that we wrote for certain things, but I only store 14 days and it's 50 gigs, and that's what sits down in the data center. Then
and that's what is that? 100 switches, 1,000?
That will be hundreds of devices.
Hundreds of devices.
Couple of hundred devices.
Okay.
And that, to be honest, that is probably being overly officious, downloading too much stuff than we need. This is where we're pivoting now into this being more selective and also being putting things into different swim lanes. So we use NATs as a buffer between the capture and the analysis piece, because we were struggling with the amount of transformations we were making when we received the metric from the switch. We needed to change stuff, like put labels on it or whatever it may be. So we got, at one point, it was taking 11 seconds to scrape the data from the network in one run, make all the changes we wanted to make, and then send it onwards to the storage in Prometheus. We've got that down to 5 seconds by putting a NATS buffer in between, so that I only really edit the things I need to edit when I want to. So what I like to try and now do is break this up into swim lanes. So there's like a fast lane for things that don't need to change, another fast lane for things that are on change, and then a separate slow lane for things that will be touched. And that's where I think that the information I got from the modern telemetry book, which is a fantastic thing, everyone should go and buy it. Make maybe 5 copies. But realistically, for me, that was probably the leaping off point to try and turn this into something that was more mature. And what I then realized was this is a lot of work. And that is why I'm now trying to pivot this into a public project in the open source space, to try and build this thing out, because I genuinely think if I can steal a bunch of resource from other people on the internet and they can then get the benefit coming back, we'll move forward in a significant way.
Here, I agree.
All right. Any other closing thoughts that anyone wants to share before we wrap up this show for today?
Yeah, I just posted a link in the chat that we can, drop in the show notes. The Wikimedia guys, they operate a very big network and they consume telemetry through and through. And they open up a lot of information how they run the network. They have public dashboards, so people can just have a look at their dashboards and see what data they collect, at what rate, what are subscribe intervals they use. And they're pretty much open how they configure their stack. So there's a lot of interesting insight one can tap on by just looking at that link and reading on the materials. I think the storage requirements are there as well. I did not check recently, but it was one time there. So maybe it's there, and we can see how relatively big guys consume telemetry there.
Excellent. Any other parting thoughts, guys?
I was just going to say,
all right,
dive on in deep. So don't be afraid of it. Try it out and explore. Right? That's part of an aspect. Be curious. So.
Yeah, and I'll put a sales pitch out there that says, obviously, I've already said it, I'm trying to do this in an open sense. So I'm very visible on the Packet Pushers Slack. Everyone knows my name there. Come find me. Come talk to me. If you are interested in joining this effort, so far I've got a university that wants to chuck some students at it to help with some of the development angle of this. And I've got a couple of community friends from AutoCon and the last couple of weeks of conversations who want to get more involved in trying to solve this problem for the public good. So if you're interested, come find me.
So John is on the Packet Pushers community Slack here. What's your handle, John?
You can make me say it, aren't you? I am known as Fat Red, and anyone who's on this video call knows why. It's a school name that just did not go away. But yeah, you can find me quite easily all over the internet, to be honest. As a guy who worked for a privacy company, I'm not very private. But yeah, I'm open to conversation and collaboration on this topic. I really think we need to stop the 50, 60 people who are working on this in isolation and come together to be 50 people working on one thing. Because
John,
we will have gNMI.
If you did a sales pitch, I need to have one as well, right? Otherwise, it's not fair. So I would say that if it's gNMI or Yang push, this kind of streaming telemetry is coming. So this is the freight train that's coming your way, and SNMP, if not coming away, it's fading. So people will inevitably will see more gNMI or Yang push in their networks. So if your hardware supports gNMI, I don't see a reason why you wouldn't try that. Maybe for simplicity's sake, you stick with SNMP for a little while longer, but all the more reason to try it out and see what's coming. It's like you've been watching like 480p videos all the time, and then suddenly you saw a 4K screen at your friend's house, and then you just ask like, oh, it was possible all the way. So yeah, try it out. It's there. There's a lot of goodies in the back, not only for collection of metrics and state. There's also configuration piece that's tied into that. So yeah, I would just encourage people to try it out.
And Roman, how do people find you on the internet?
I'm also part of the Packet Pushers Slack. They will find me as Roman Dodin. That's my handle, as easy as that. And yeah, I'm also part of the different network automation communities, so all over the place.
Josh, why don't you let people know how they can find you on the internet?
I'm also on the Packet Pushers Slack channel. I'm on a few other Slack channels as well, Networked Codes, and tried on Blue Sky, other social medias, LinkedIn as well. You can find just a few links off my blog site that starting to get more active, but not as much as have been, but josh-v.com.
And Ryan Shaw.
The Packet Pushers and LinkedIn, and then a couple other, yeah. I'm a little bit more private than John.
Okay, guys, thanks for a great conversation. This is exactly what I was hoping for. Lots of great perspective on all of this. We are in the middle of a transition, which is odd coming from the networking industry, because it seems like the old technologies just never die. But some things we're starting to see, actually, as Roman put it, fade out. Some things are really fading out. Well, thanks for listening to Heavy Networking today. If you would like us to create an episode to help you solve some kind of a technical challenge that you're facing, you can let us know via packetpushers.net/follow-up. That's what Nikolay did. And we will do our best to recruit folks that have answers and share the community knowledge. Heavy Networking is the flagship podcast of the Packet Pushers network of podcasts, newsletters, YouTube videos, and blogs for your professional career development. And our work is funded by vendors who sponsor us. So if maybe you're at a vendor and you'd like to sponsor the Packet Pushers and create some great content for IT practitioners with us, hit the sponsorship form at packetpushers.net. Look right up there in the header and you'll see it, and we will be in touch. So if you're out there listening still, please do all the things like subscribe, comment, tell your friends, and you can buy some merch at store.packetpushers.net. I've been Ethan Banks along with Drew Conway Murray. We're your co-host each and every week. You can find us on LinkedIn. You can connect with us, and please do. Last but not least, remember that too much networking would never be enough.